Welcome to the Deep Dive. Today we're tackling something that's, well, it's not some far-off sci-fi idea. It's happening right now. We're seeing this unprecedented pace of change, maybe even a paradigm shift in how software gets made. So our focus today is squarely on artificial intelligence, AI, and how it's fundamentally reshaping the entire software development lifecycle. The SDLC. We've pulled our insights from a couple of key sources, a really comprehensive guide on using AI in design and development, and also an in-depth analysis looking at AI's direct effects on software engineering itself.
And our mission here really is to boil all that down, to pull out the crucial insights and give you a shortcut to really grasping this revolution. We want to show you how AI is very much a present-day tool, not just theory. It's actively changing development as we speak.
Exactly. And for you, the listener, getting your head around this shift has some pretty direct benefits. We're talking increased efficiency, seriously elevated code quality, and just the ability to build software that's more robust, maybe even more intelligent. And hopefully we can do this without making you feel buried under jargon. So let's dig in. Okay, so let's start with the big picture. The traditional SDLC, it's often been pretty manual, right? Relies heavily on people and, well, it has its limits. So what happens when AI, enters the picture?
That's where it gets really interesting. AI doesn't just tweak things. It adds this critical layer of intelligence and automation right across the board. It's not just about going faster, although that happens. It makes the whole flow much more streamlined, more predictive, and just way more efficient. It goes beyond just speeding up the human steps.
Okay, let's unpack that. For developers, for teams, what are the sort of core benefits we're seeing from this AI infusion?
Well, first off, speed. Increased development speed seems like a big one. AI automating repetitive stuff, generating code snippets.
Yeah.
That obviously cuts down timelines. It does, significantly.
Yeah.
But it's also about how it speeds things up. By taking over the boilerplate, the mundane tasks, it frees developers up. They can then focus their brain power on the harder architectural problems, the really creative solutions. That's where humans excel.
Right. And alongside speed, you mentioned quality, improved code quality. How does that work?
Well, you've got these AI-powered tools now for static analysis, bug detection, even code review assistance. They're finding and flagging issues much, much earlier, sometimes literally as the developer's typing the code.
So cleaner code from the get-go.
Exactly. More reliable, less buggy.
Which I guess naturally leads to fewer human errors slipping through.
Precisely. Automating those complex, fiddly tasks where it's easy for us to make a mistake that directly boosts the overall stability and quality.
Okay, and you mentioned something else earlier. Predictive maintenance. That sounds pretty advanced.
It is, and it's incredibly powerful. Think about AI algorithms crunching through system logs, performance data, and actually identifying patterns that suggest a potential failure before it occurs.
So it's proactive, not reactive.
Absolutely. The goal is to prevent the failure entirely, or at least give you a warning, minimizing that costly downtime.
Okay, so that's the high-level promise. Increased speed, better quality, fewer errors, even predicting problems. Sounds great. But let's get practical. How does AI actually impact the day-to-day work, going through the SDLC phase by phase? Let's start at the beginning. Requirements. That initial phase, gathering requirements, it's notorious, isn't it? Often filled with ambiguity, potential misunderstanding.
Oh, definitely. It's a classic bottleneck.
Yeah.
But this is an area where AI, especially natural language processing, NLP, is making huge strides. Imagine AI tools reading through user feedback, support tickets, market research docs, and automatically pulling out the key functional and non-functional requirements.
So it's sifting through all that raw data.
Exactly. And more than that, large language models, LLMs, can scan the requirements documents themselves. They can spot vague language like the system needs to be fast. Well, what does fast mean? Or find conflicting statements, ensuring clarity before you start coding. And they can even help product managers or BAs generate properly structured user stories, maybe even with suggested acceptance criteria, just from a high-level feature idea.
That's incredible. Starting with requirements that clear, you're setting yourself up for success right from the start. I know tools like Jama Connect are doing things in this space, and people build custom NLP scripts too.
Yep, it's becoming more common.
Okay, let's shift gears to phase 2, coding. This is where it gets really interesting for developers, I think, these AI coding assistants.
They're becoming indispensable tools, honestly. The impact is really tangible here. You have LLMs trained on just vast amounts of code. They can predict what you're trying to do, generate code snippets, functions, sometimes even whole classes.
Based on comments or just the context?
Both. Natural language descriptions and comments, or just understanding the surrounding code. It's like having this enormous library of patterns instantly available.
And it's not just generation, right? It's also about fighting problems.
Absolutely. Tools integrated right into the IDE, your development environment. They analyze your code as you write it. They flag potential bugs, security flaws, performance issues, giving you immediate feedback.
Like a real-time code review.
In a way, yes. Plus, they can suggest refactoring options, ways to make your code cleaner, more maintainable, or perform better.
It really does sound like having a super smart coding partner sitting next to you. We're talking tools like GitHub Copilot, Tab9, Amazon Code Whisperer, Snick Code.
Those are the big players right now, yeah.
Okay, code's written. Now, quality, testing and QA. The big goal here is always shift left, right? Catch bugs early.
Exactly. Find and fix things as early and therefore as cheaply as possible. And AI is a massive driver for shifting left. For instance, AI can look at the requirements in the code itself and automatically generate test cases.
Including the tricky ones.
Yeah, it's often better at thinking of edge cases that a human tester might overlook, so you get better test coverage.
And what about running the tests? Automation.
AI is improving that too. Intelligent test automation. Frameworks that can prioritize which tests to run based on recent code changes or risk analysis. They can also sometimes identify flaky tests. Those tests that sometimes pass, sometimes fail for no obvious reason, and even attempt to self-heal them.
Oh, flaky tests are the worst. That's huge.
It saves so much time and frustration in CI/CD pipelines. And if a test does fail consistently, AI can analyze the logs, the execution flow, and help pinpoint the likely root cause of the bug much faster than a human digging through everything. Less debugging time.
So it really flips testing from being reactive to proactive, making quality more inherent. You mentioned platforms like Testum, Apple tools, and even traditional tools like Selenium and Playwright are getting AI enhancements.
That's right. They're becoming smarter, more adaptive.
Okay, coding, testing. What about getting the software out the door? The CI/CD pipeline, continuous integration, continuous delivery. It's the backbone, really.
It absolutely is. And AI is helping make that backbone stronger and more efficient. Take build failures. AI can analyze historical build data, which commits caused failures, what kind of errors occurred, and actually predict if a current build is likely to fail.
Giving developers a heads up before it breaks the pipeline.
Exactly. Address potential issues proactively.
Makes sense.
And in cloud environments, with containers, AI can get involved in optimizing resource allocation for the CI/CD jobs themselves, making sure you're not overspending, making the pipeline run faster.
Smart resource use.
Yep. And maybe most critically, post-deployment monitoring. AI can watch how the application is performing after a release. If it detects anomalies, sudden error spikes, increased latency that correlate with the new deployment, it can trigger an automated rollback to the last known stable version.
Wow, an automated safety net.
Minimizes the blast radius of a bad release. It's like having an intelligent guardian watching over your deployments.
And you'd integrate this with monitoring tools like Datadog or Dynatrace, feeding that info back into Jenkins or GitLab CI/CD.
That's the typical pattern, yes. Closing the loop.
Okay, we've covered almost the whole cycle. Requirements, code, test, deploy, monitor. But there's one piece that often gets, well, neglected. Documentation.
Ah, yes. The bane of many developers' existence. But AI is tackling this too. It's making documentation generation and, crucially, maintenance much less painful. Almost effortless in some cases. AI tools can scan your code.
The actual source code.
Yeah, the source code, and automatically generate clear, up-to-date documentation for APIs, for functions, for classes.
So the docs reflect the current state of the code.
That's the goal. And something really cool that's emerging is the ability to query your code base using natural language.
Like asking it a question in English.
Exactly. How does this authentication function work?
Right.
Or where is user data stored? And getting a precise answer based on the code and its comments.
That sounds revolutionary for understanding complex systems.
It could be. And by integrating with Git or other version control, AI can automatically update the documentation whenever the related code changes, keeping it in sync.
Goodbye, stale docs. Tools like Mintlify, DocuWriter.ai, they're making this real.
They are. It's a rapidly developing area, saves a ton of time, and ensures the knowledge base is actually useful.
Okay, so we've toured all these different phases where AI is making an impact. But let's truck and tie it all together. What does this look like in practice for a real project, start to finish? Let's talk about this concept of an end-to-end dev intel platform, maybe using our sample e-commerce web app as an example. building a new feature.
Right, so this DevIntel platform isn't one single monolithic thing. Think of it as a suite of interconnected AI services, each enhancing a part of the SDLC. The real magic is how they work together. The synergy creates this intelligent, self-optimizing workflow. It's more than the sum of its parts.
Okay, let's walk through building a new product review and rating feature using this DevIntel idea. Phase 1, requirements and design. You called it the clarity service.
Yep, clarity. Objective. Crystal clear requirements. Solid initial design. So you feed it the product requirements document, the PRD, for this new feature. Maybe it's plain text. A fine-tuned AI model, maybe GPT-4 based, parses it. It identifies the functional requirements, the non-functional ones, and importantly, it flags ambiguities. That system should be fast example. It'll say, hey, define fast. What's the target response time?
So it forces clarification up front.
Exactly. Then it generates consistent user stories, maybe even suggests test cases in Gherkin format, given when then.
Which testers can use later.
Right. And the output.
Yeah.
Maybe a structured JSON file, something easily version controlled in Git.
Okay, phase 1 done. Clear requirements. Now, phase 2, development. The Velocity ID hack plugin.
Velocity, yeah. Goal. Speed up coding, improve quality. The developer's working in their usual IDE, but it's enhanced. GitHub Copilot is there, generating code from comments like API endpoint for submitting reviews. Snick code is running in the background, scanning for security issues in real time.
Providing instant feedback.
Instant feedback, fix suggestions. And maybe another AI tool, perhaps a custom script or something like diff blue cover, is automatically generating unit tests for the new functions the developer just wrote.
Okay, code's getting written faster and cleaner. Phase 3, CI/CD and testing. The Guardian pipeline.
Guardian, objective. Automate testing, ensure quality, streamlined deployment. Code gets pushed, GitLab CI/CD kicks off, first stages, AI-powered linting, static analysis, maybe deep source, catching deeper issues than basic linters. Then, run the unit and integration tests. Then, the intelligent end-to-end tests. It uses those Gherkin files from the Clarity service with a smart framework, like Testum, that can handle flaky UI elements better because it understands the intent, not just the specific CSS selector.
Adapts to changes.
Right. Then, an AI-boosted security scan, maybe OWASP as app, but with AI prioritizing the most critical vulnerabilities found.
Focuses the effort.
Exactly. If everything passes, conditional deployment, maybe a canary release to start.
Smart rollout. Okay, it's live. Phase 4, monitor and maintenance. The Vigil service.
Vigil, keeping watch. Objective, proactive monitoring, predictive maintenance. You've got an AI-powered observability platform, New Relic. Or maybe Prometheus Grafana with an AI library like Prophet. It's watching performance, errors, resource use. The Vigil service analyzes this stream of data constantly.
Looking for?
Anomalies. A sudden jump in latency for that new review submission API, and it flags it. But it also tries to correlate. It might say, latency increase detected, likely related to deployment X in these specific log patterns. Gives you a starting point for investigation.
And over time, it learns.
Over time, it builds models to predict potential issues before they impact users. Gives you that crucial heads up.
Amazing. And finally, phase 5, documentation. The Scribe bot.
The Scribe. Objective, keep docs current and accessible. A successful deployment triggers the bot. It uses something like Mitlify or a custom model to scan the newly deployed code changes. It automatically updates the API documentation, new endpoints, parameter changes, examples, and pushes it straight to the developer portal.
So the docs are always truly in sync with the code.
That's the dream.
Wow. Seeing it laid out like that, how these AI services connect across the entire life cycle, it really paints a picture of an intelligent, almost self-optimizing system.
It's a cohesive workflow, yeah. Each part makes the next part smarter and more efficient.
Which brings us to the maybe the elephant in the room for some listeners, this big question. With AI doing so much, will it replace human developers?
Yeah, that question comes up a lot. And the sources we looked at and the general consensus in the field right now is pretty clear. No, AI isn't here to replace developers. It's here to augment them, to act as an incredibly powerful collaborator.
Making developers more effective, not redundant.
Exactly. Think of the future developer as a human-in-the-loop expert, someone who guides the AI, leverages its power, but brings the critical thinking, the context, the creativity.
So the focus shifts.
Definitely. Less time spent on writing boilerplate code, more time on the really challenging stuff. System architecture, complex problem solving, user experience design, and also, importantly, ensuring the ethical and responsible use of AI within the software itself. That requires human judgment.
Right. So connecting back to the big picture, it's really about elevating the developer's role, making them more strategic, more innovative, focusing their unique human skills where they add the most value.
Precisely. Moving up the value chain, as you said.
Okay, so just to wrap things up, the core message here seems to be that AI isn't just another tool we're adding to the SDLC toolbox. It's fundamentally rewriting the process, making software development faster, yes, but also higher quality, more resilient.
Absolutely. And embracing this AI-driven approach, starting to integrate these capabilities, that's what's going to position developers and their organizations at the forefront of what's next in software engineering. It's genuinely an exciting time.
It really is. Which leaves us with a final thought for you to mull over. As AI increasingly handles the more repetitive, predictable tasks in software development, how will you adapt? How will you redefine your own creativity, your problem-solving skills, to ensure your unique human contributions become even more valuable in this evolving landscape?